So our first section on probability is talking about set theory, which is basically using set notation, talking about set notation, different types of sets, how we notate the set, how we describe relationships between sets, and how we notate those. So that's what we're doing today. So first of all, a set is a collection of elements. We call the members of a set elements. And that could be numbers, it could be letters, it could be colors, it could be ages, it could be names, it could be any kind of thing, any kind of sort of object or item that we have a collection of. So for instance, I'm going to do, let's just go with single digit numbers. It's a pretty common set to work with. Single digit integers is really what that is. Okay, so a universal set would be basically the set you are pulling from, the collection of all the elements of a certain type. It's kind of like the parent. The full set of all possible elements. And we're talking about all possible elements for your whatever. For instance, if you're doing a probability problem where you're pulling socks out of a drawer, the universal set would be all the types of socks that are in that drawer. It doesn't have to be all the socks that exist in the world. If you are dealing with something where you are drawing numbers out of a hat, it would be all the numbers that are in the hat. Okay, so the full set of all possible elements. So like for instance, 4 single digit integers, yeah, that would pretty much be the whole thing. If that's what we're talking about, then that's our whole set. A subset is a smaller group basically pulled from a set. Like for instance, if I said all of the single digit numbers smaller than 4, that would be a subset. So that would be just 0, 1, 2, and 3. Or I could say all of the I don't know, odd numbers. Okay, or it could just be, random numbers. It doesn't necessarily have to have a defining characteristic. It could just be 1, 3, 4, 7, and 8. Okay, just a smaller group that has elements out of your universal set, but is not the entire set. So that's a subset. So when we're talking about sets, first of all, we do use brackets. If you have trouble doing the sort of curvy bracket, if you have trouble doing that, you can use a square bracket instead. Don't use parentheses because parentheses have their own specific meaning, like ordered pairs. Okay, so make sure you use brackets of some type. All right. When we talk about sets, we like to talk about their intersection and their union, which are the two first concepts that we're going to look at here. So an intersection is all of the shared or common elements from multiple sets. It could be 3 different sets. It's very often 2 sets that we're talking about, but it could be more than 2. Okay, we like to think of the intersection as sort of like the overlap. So the elements they have in common. Thank you. Okay, thanks. Let me go ahead and, okay, the symbol for an intersection is like an upside down U. All right, so we have these 2 small sets, 2 subsets. C is has the elements 7 and 8 in it. D has 7 and 11. So the intersection of those 2 would be just 7. Okay, that's the only element that is in both groups. Okay, so sometimes we talk about intersection as being and it's not and. There's a very specific way we have to talk about how it's and, because it's not and like this group and this group. It's more like individual membership. My thing is a member of the intersection. My element is a member of the intersection if it's in this group and it's in this group. Okay, so 7 is in the intersection because, that's shorthand for because, it's in C and in D. It's in both groups. Okay, so the union of multiple sets is the set of all elements which are in any of the sets we're talking about. So you could think of the union as all. I know another teacher who thinks of the union as the marriage of the sets. The symbol looks like a U. All right, so the union of C and D, which is what this is asking for, would be everything that's in either of those sets. So 7, 8, and 11. So again, thinking about the and versus the or, we're thinking about, does it qualify for that group? If something is in the set, if something is in a union of two sets, then it's in the union because it's in one set or the other. So we could say that is an or situation, like 8 is in the union because it's in C or D. And the reason I'm trying to talk about bringing in these words and or is because it has to do with how we look at them visually, how we look at union and intersection visually when we start doing Venn diagrams of them. Another thing to be aware of here, when we use the word or here, we're using the inclusive or, and what that means is it could be in one thing or the other or in both. Both counts as or. It's like if I said, you can run for class office if you are a rising sophomore or you have an AB average. Well, if you are both of those things, then you would assume that yes, you can run for class office. So yeah, it does include members that are both of the things. All right, so complements. Complements of sets is everything that's not in that set. Okay. I don't know if I want to use the word a. Hang on. Yeah, let's do all of the elements not in a particular set. And that's the word we use a lot of times to describe it, is not. We'll say like not C, not D, not P, to talk about not being in that particular set. There's actually 3 ways this can be notated. And I'm going to say, since we have it down here, set A, you could have a little apostrophe, and that means not A. You can have a line over the top, which means not A. Or you can have a little squiggly out in front. That means not A. Those are the 3 different ways that sometimes you'll see it notated. All of those are just different ways of saying everything that's not in A. You have to know the universal set to be able to say not something, okay, to be able to describe a complement. If I gave you a set and I told you to describe everything that was not in that set, you wouldn't, you could just go on forever listing numbers and letters and colors and people, and you have to have some sort of boundary. So in other words, if we're saying not A, which we're going to go ahead and write it that way, not A, then we're saying everything that's not an A out of this group. You need to know what your universal set is. Out of who? Out of what? Okay, so out of this group, everything that's not an A would be 0, 1, 3, 4, and 6, I think that's it. So that is not A. Together, if you take a set and you take its complement, together the two of them make up the universal set. Because all possible elements are either in a set or they're in its complement. All right. On the back here, set theory examples. A large bag holds marbles of the following colors: blue, green, orange, and pink. A small bag holds marbles of the following colors: red, green, yellow, and orange. One thing you'll notice about this particular set of worksheets is they're pretty good about picking different set members that have different first letters. So we're going to talk about this as B, G, O, P, and so on. Okay, define the universal set. So the universal set is all the colors that have been mentioned here. So I'm going to say B for blue, G for green, O for orange, P for pink, red. Green was already mentioned, so I wouldn't put it in there twice. If something's in a set, you don't have to name it more than once. Y for yellow, and orange has also already been mentioned. So there's my universal set. That's the set of all the colors mentioned in either bag. If they had said that there were also some rolling around on the ground that weren't in a bag, I would mention those in the universal set too. Okay? Any of the colors that we know happen. We know these are the colors of marbles that exist. Okay, define the two subsets. I'm going to use an L for the large bag and an S for the small bag. The large bag has blue, green, orange, and pink. Notice that when I'm listing elements, I put commas between them. The small bag is red, green, yellow, and orange. So those are my two subsets. Now, when we create a Venn diagram for this, what we're going to start with, and it doesn't always have to be a rectangle. It could be a larger, like oval or something. But generally, we use a big rectangle as sort of our outside boundary for the universal set. Okay? And then we draw however many circles we have subsets. However many subsets we have a circle for each of those. It's helpful to stop and think about whether or not there is any overlap between our sets. If there is anything in the intersection of the two sets. Are there any elements that show up in both sets? Okay? Because you got to make sure your circles overlap if your groups overlap. It is possible to just always draw your sort of circles. They don't have to be perfect circles. They could be more oval. It's possible to just draw it like that always. And then if there's not any overlap, you just don't put anything in the middle part. That's another option. Okay? But I'm going to go ahead and label my two sets. This is the large bag. This is the small bag. And generally with a Venn diagram, you want to start with your intersection. That's a good starting point in general. Okay, my intersection of these two sets, the items that are in both are which two colors? Green and orange. So I'm going to put a G in here and an O here for green and orange. And then on the large bag side, these two are in the large bag, and I have to, outside of here, not in the small bag also, put the colors that are in the large bag that aren't in the small. So that would be blue and pink. And over here, I'm going to put the colors that are in the small bag that are not also in the large bag, and that would be red and yellow. If there were any colors, like marbles sitting on the table that were not in either bag, they would go out here. Okay, the rectangle, the big outer rectangle represents the universal set. Okay, so everything fits into there. In this case, all the colors mentioned are supposedly in a bag. So find the intersection and union of the subsets. All right, so the intersection, I'm going to put them over here, intersection of L and S, and it's really not a U. It looks a lot like a upside down U, but it's not a big deal if you draw it. The intersection is anything that's in both the large sac and the small sac, and that we already said is green and orange. So the intersection of your sets is also at the intersection of your circles. And then the union is everything that's in either circle or both. So anything that's anywhere in any of this, so like you could think of it like anywhere in there, all of that's a union. So blue, pink, green, orange, red, and yellow. In this case, the union of those two sets happens to be the universal set because there's none that are outside the bags. That's not always the case, though. If there are any that were outside the bags, then that would not be the exact same. So we just did this up here. Questions there? All right, example, suppose a universal set consists of all the single-digit positive whole numbers. Does that include 0? No, because, yeah, positive means greater than 0. So 0 is not greater than itself. Positive, 0 is not positive. Okay, so defining the universal set, which I like to put a little tail on my U when I'm saying the universal set, just to make sure it's clear that I'm talking about a universal set, not a union of sets. So the universal set here is 1 through 9. My two subsets are the set of all even numbers out of that set and the set of multiples of 3 out of that set. So out of that set, even numbers 2, 4, 6, and 8. Multiples of 3 would be 3, 6, and 9. Now we're going to draw a Venn diagram to represent these sets, but as I pointed out earlier, your best place to start with a Venn diagram is very often the intersection. So let's go ahead and look at what that is since we're asked about that over here. The intersection of E and M is the set of all elements that are in both, which is what? 6. So I'm going to draw my circles to represent E and M, and I'm going to put 6 where they overlap. So then I can go ahead and fill in the rest of circle E and the rest of circle M. So go ahead and do that. And so we've got 2, 4, and 8 over here, and 3 and 9 over here. And are there any members of the universal set that are not in those circles? That's a yes. There are. 1 is not in those circles. What else? 5, and what else? 7. Okay. So if we're asked to find, this is not E, that's how we read that, not E, or the complement of E. We're being asked to list everything that's not inside that circle of E. So like, don't forget the circle goes over here. So it does include 6. Everything that's not inside that red ring goes into my set here. So 1, 3, 5, 7, 9. And that shouldn't be too surprising because those are the odd numbers. And everything that's not even would be odd. Number 10, this is saying everything that is not in the union of E and M. So it helps to think about what is in the union first. So the union of E and M is everything that is in either of these circles. And I'm going to rewrite this a different way just to show you different ways it can be written. That's another way to say the same thing. Everything that's not, so this is the union, and then it's saying not that would be 1, 5, and 7. Those are all the things that are not in the union of E and M. Okay, I want to give you another one to find. Let's say we've got this and this. See if you can figure out what goes in this group. What do you notice up here? It's the same as this. This is the intersection of not E and not M. In other words, it's everything that is both not in E and also not in M. The things that are not in E is 3, 9, 1, 5, 7. The things that are not in M are 2, 4, 8, 1, 5, 7. The only ones out of those that are in both of those groups, the intersection of those two groups, is 1, 5, and 7. So this is another way of expressing the same thing. Questions there? All right. Looking at this next page, Mrs. Austin has 10 students in her class. She asked them whether they like football or basketball. Sarah, Alan, Kara, and Todd, all different first letters, so you can call them S-A-K-T, said football. Joseph, Lydia, and Matt said basketball. Caleb and Brittany said they like both. Ethan said he didn't like either. Define the universal set. So the universal set is all the students. How many students are there? 10. So make sure you end up with 10 letters once you've finished collecting all the people's names or turning them into letters. I just went in order through the sentence and pulled out letters for each person's name. Now, when you define the two subsets here, please remember that Brittany and Caleb, B and C, said they like both. So they are in the football subset and they are in the basketball subset. So go ahead and define the football subset F and the basketball subset B. Okay, see if you got the same thing as me. Your intersection should have Brittany and Caleb in it. I don't really like that these are single letters. Let's do this. Football, basketball, because it might be confusing that this is a B and that's a B. Don't forget to put Ethan outside the circles because Ethan said he didn't like either one. Now, what I want you to look at is look at numbers 4 and 5 and go ahead and try those two. And then as soon as you've done 4 and 5, jump down to 8 and 9 because they go with 4 and 5 very nicely. Okay, so here's what we got for 4 and 5. 4 is just the intersection. 5 is the union, so it's everything that's in either circle, including the two that are in both. And then once you've got 4, 8 is the complement of 4, and 9 is the complement of 5. So everything in the universal set that's not B or C goes here. And everything in the universal set that's not E, excuse me, that is E, everything in the universal set that's not one of these, which is E, goes here. 4 and 8 are complements of each other. 5 and 9 are complements of each other. Questions about any of those? Let's go ahead and finish up with 6 and 7, not F and not B. Questions on those? Let me know if you need help on any of those, and then we're going to do a couple that are just a little bit more complicated because these are pretty straightforward. It means the same thing as the apostrophe. It means not in this set. Okay, so let's try, I'm going to call this 9B and 9C. So try to find those two. A little bit more complicated. Okay, here's my answers. You can compare yours. This is the intersection of not F and B, and I got J, L, and M. This is the union of F and not the intersection of F and B. So let's kind of unpack these a little bit. Not F intersect B. Okay? So it helps to think about what's not in F. Not in F are these four. So this is J, L, M, E. B is B, C, J, L, M. Those are all the things in B. If we want the intersection of those two things, then we're talking about the stuff that are in both groups. So J is in both, L is in both, M is in both. So that's my answer, J, L, and M. Questions there? Other one's a little harder, okay? It was F union, not the intersection of B and F. Okay, so I'm going to work my way out here. First thing is I'm going to figure out what is in the intersection of B and F. Let's just do that over to the side. Intersection of B and F is B and C. So this says not that. So not that would be everything else. So S, A, K, T, J, L, M, and E. So that's what's here. S, A, K, T, J, L, M, and E. I'm doing the union of that with F. Well, F is S, A, K, T, B, and C. F includes B and C. So if we're doing a union, then that union brings B and C right back in. All together here, we have everything. We've got B and C, we've got E, we've got all the letters. So all 10 letters are in this group. So that's why I had S, A, K, T, J, L, M, N, B, C, E. So the fact that all of F has to be included includes B and C, because B and C are in F. Okay? All you have to do for homework is finish the back of this sheet, and tomorrow we'll do some more practice with the Venn diagrams.